Well, greetings and salutations. Um, have a neat little show tonight because I keep getting pestered in the in my comment sections uh, because of the stupid claims made by stupid people over at the Flat Earth debates, haha, so aptly named, on Nathan Oakley's channel. Their argument is very simple. They say that Earth curve calculators do not, I lose you, do not account for perspective. Now, let's not forget one thing. Flat Earth perspective is a magical animal. Okay? Flat Earth perspective makes the sun disappear and fall and disappear from the bottom up without actually disappearing out of sight, without ever getting smaller. And yet airplanes fly away and you can't see them after they get to a certain distance away. That's flat Earth perspective in a nutshell. Apparently, the sun gets so far away that you can't see it anymore. However, its light still lights up the sky above you, et cetera, et cetera, et cetera. I mean, I can go on and on and on about all the flat Earth perspective. Scott, and so here's here's what I wanted to put together here. It's real simple. Um, well, let me just first say, until somebody actually maps me out exactly what flat Earth perspective actually does do, besides fill in the gaps for all the things that flat earthers can't explain without destroying their own claims. Perspective is nothing more than angular size. Okay, angular size. The thing that I showed in the perspective video. Even laid it out in crayon for him. Still screwed it up. So, tonight I'm just going to show very quickly. I've modeled this out to scale, and despite what some flat earthers have attempted to say, that apparently I can't 3D model because apparently I might be faking things, even though they showed a 3D model of wind turbines that was deliberately manipulated to look like something it wasn't, and it was stated by flat earthers that it was modeled after something that it wasn't, as per the modeler himself. So, oh my god, this stuff just goes so deep, man. So deep. Um, I'm going to be showing, quite simply, a 3D model that I made in 100% profile view. 100%, well, this one's going to be in perspective, of course, but showing that Earth curve calculators do take perspective in because they can't get away from it even if they tried to. Okay? So, here's what I've done. First, let me get this back out of this mode. What I've made here is like I've made about a dozen times before. I have made a stretch of surface. That's the purple surface. Okay. I've made a stretch of surface that is 55.66 units long, otherwise known as a half a degree if you were to translate that to kilometers. A half a degree of curvature of the Earth. Then what I did, actually, let me go back to front view. Blah, all kinds of ugly there. Okay, then what I did was I made this cute little stick for measuring. Okay, 10 meters each. Marked it off from this direction and also from the other direction. That's what you're seeing right here. This kind of off-colored little block here. That's so you can see it from the camera's direction. And then what I did was I put a little circle here at the top, little circle here at the bottom. They are attached to this moving ruler. And then I put these two blue lines, which go all the way back to the camera. Okay, they're attached to these two little gizmos in here. And they attach to the camera. And they will stay pointed at those circles at all times. For those of you who know about using 3ds Max, they have a look at constraint on them and will not budge. Please also note that I have the fake the globe button removed. Fake the globe button that all CGI has. Yeah, it's I don't have it on today. Then I have a camera that's attached to this one. You'll be able to see that in the view that doesn't that stays static with the ruler. I have marked off here exactly all the way up to 55. Obviously, the 0.6 is off a little bit further, but we're only going to worry about the 55. And then what I did was I set it up along a track. This pink line here is a track, but I'm going to go ahead and I'm going to make that line not pink anymore. I'm going to make it black so it doesn't confuse anybody. Hold on. So you can't really see it in the view because that will confuse somebody because it remains in the middle the entire time. What that track is that track remains at 50 meters above the surface here the entire way along. And then what I did was I just animated along that track that this ruler here will go along that track all the way to the front and back. Pretty simple. Now I put this nice big fat arrow on here so you can actually see it a little bit better from a distance because, well, these things are kind of small. Cool? All right. And and then I have another camera here looking at the camera that is looking downrange. Reason why I have that camera there is just so you can see something that's going on as I'm moving the slider. Now here's the first thing I'm going to do. Okay. This is the cam, the one that's looking at the camera. Okay, the camera is, the camera is 20 meters above the surface of, in this case, the curved Earth. Target cam, that's the one that's following this, the ruler, and it will not change its position with relationship to the ruler itself. It's actually moving with it. Okay, and then I have the camera 1, which is basically just looking at the entire setup from the side. And then I have camera 2. Camera 2 is the one that's actually down here looking downrange. Okay? Now, first thing to tackle here. If the Earth curve calculators, to include Metabunk or the what's the other one, GitHub or something, if they didn't include angular size, otherwise known as perspective, if it didn't include that, then these two blue lines that I was just showing you a second ago, the ones that are linked to the bottom and the top, and then going back to the camera, these would never change in size, ever. Okay, they would remain at the same angular size the entire time. That would be a direct representation of flat Earth calculator, or flat Earth. Wow. Earth curve calculators not taking into account perspective. However, if they move even just a little bit, then guess what? That means they take perspective into account. Now here's what I'm going to do. I'm just going to bring this all the way down here. Now I can just start like right here. Okay, it's way back here at I would say about the 100-meter mark. See the blue line here? Okay, you can even see it in the ruler view. Okay, it's looking up at the top, it's looking at the bottom. That means in the camera, as you can see here in the camera, and I will go like this, it's pretty damn big. It takes up more than the camera size. Okay, now I'm going to move it away just a little bit. And as you can see, in all locations, the same thing. The angular size is getting smaller, but the object itself, no Riley, things don't get smaller twice, is getting smaller in the view. Angular size is getting smaller, but the target is remaining the same height. Okay? And I'm just going to move right on along here, pushing it out. Now I'm at 4 kilometers, 6 kilometers, By the way, every 10 on my scale here is 1 kilometer. So that's 8 kilometers, 10 kilometers, 12 kilometers. Do you see what's happening here? This is getting smaller. You've watched it on both sides. You've seen it from the full view. You've seen it at the target location. You've seen it at the camera location. Hence, Earth curve calculators mathematically take into account perspective. Period. They wouldn't work otherwise. They don't have they just wouldn't work otherwise, okay? That's just about as simple as I can take that. Now, before you say that this isn't exactly how the Earth curve calculation is made on Metabunk or on the Earth curve calculator from GitHub, well, let's just take a look at that. Somebody from my chat, please give me a. Now I'm going to leave the camera at 20 meters. Give me a distance somewhere between, well, I would say up to 40 kilometers. Okay, because after that, I think it completely disappears and is completely hidden. So somebody give me a number. First number I see. I said below 50, dude. Yes. Okay, 39. Thanks, Pate. Okay, 39. So we'll go all the way out to 39 kilometers, which is 390 in my slider here. This is at 39 kilometers right now. You could see it right here. Okay, now I'm also going to take this camera 2, and zoom it in a bit, because obviously it's gone way away. Camera 2. Okay, and let's go ahead and zoom in by reducing the field of view. Oops, wow. Let's go to 0.5, 0.5. Okay, so do. Okay. Oh, come on. Really? Sorry, my internet was messing with me there. Okay, now I'm going to show you guys I'm doing this here. Okay, now what do you see here? It's right about 40, right? Actually, just a touch over 40, right? This line, by the way, excuse me, I forgot to mention this. This line right here is the center of the camera view, which I have also, now we're at 39, so we'll come back to that, which I have also made the horizon, which is like right around here. Okay, meaning that that is the lowest unobstructed that can be seen from this 20-meter height. Now, I'm sorry, let's go back out to 390, which is 39 kilometers. Okay, like I said, these ticks are all, yeah, these are all 5 meters. Sorry, 10 meters, 20 meters, 30 meters, and you got a fiver in the middle. Anyway, this is, I'll type it again here just so everybody sees. I'll just do 50 for a second. Okay, that's wrong. Okay, so we'll go back to 39, which is what we just selected. In meters, viewer height in meters, 20 meters. Hidden height. We're not going to go into the refraction thing because flat earthers don't get that anyway. But hidden height, 41.65. Look at this. That is just under 42 right there, guys. Okay. I mean, is there anything else to say? Somebody else give me a number. Come on, we'll do 3 more. A number between 10 and 50. And no decimals. Actually, I could do single decimals. just by the way I have this set up. $25. Okay, I got the boss here at 25. So let's see. Distance in kilometers, 25. That's going to put me at hidden 6.41 meters. Oops. Whoa, way too far. 25. 6.41. That looks pretty much like that right there, doesn't it? Okay. Now, sorry, gentlemen. Got a lady in the audience. She said 33. Let's go for 33. 33. Okay. We'll go for 33. 33. Hidden height. 2.78. Or 22.78, excuse me. Yep, that's right about 23 right there, huh? You got what I'm saying, guys? So, not only is the Earth curve calculator correct from Metabunk, thank you, Mick West, and also thank you, GitHub, on the other one. I didn't have it here because there's just a lot more information on this one. Not only is it correct, it also shows perspective, as you saw right here. As things get further away, they get smaller, which means their angular size reduces. Let's see if I can get one right up here to right around the 100 mark. Now the 100 mark is 51.7 kilometers. 51.7. Look at that. Right at the 100. Are you getting me now? What? Wooden, you're also a lady. Give me a number. Every time you divide by 0, another star falls in the black hole. Wooden, you're supposed to give me a number. 13. Lucky number. Okay, so 13 kilometers. Now let's find out what we got here. Hidden, none. Okay, understand that. Hidden is none. So let's go way back to 13. Now what you're going to see here, this line right here, like I said, is the center of the camera, which is also the horizon line, the visual obstruction line, which means you can't see below that. However, going back to here, you're going to see it touch, and then you're going to see it come back up. Okay, now it's coming back up. Now we're at 13 kilometers. Nothing is hidden because the line is coming back up. That means it is not beyond the visible horizon, the geometric horizon, the horizon period from a viewpoint of 20 meters. As stated also here, none. The horizon is beyond the target distance. Simple enough, guys? Yeah, I heard somebody told me that they were talking about electrolysis today and sulfuric acid and all this other shit, but I figured I'd leave the chemical stuff up to Gil because he's a chemist. So, but anyway, that's all I really wanted to show on this. Things get smaller, or things appear to get smaller due to distance because of their reduction in angular size inside of your field of view. I just showed you that if this was not, if the Earth curve calculators did not take into account angular size, which they do, then the measurements would be way off because every one of them would start out being about this big and stay that way, which they do not. Okay? So that's all I really had to put out tonight, guys. I have a very interesting video coming out tomorrow because it's going to be one of the 4 videos that I'm going to be putting out because you see, Sly actually uses his donation money to buy things. Mind you, I don't have Jeranism money or anything like that, but to buy things to perform experiments with. And you guys are going to see that over the next couple of days. And the first one, I figured I'd just straight up just tick everybody off. Okay? So, ladies and gents, perspective is in the Earth curve calculators. Otherwise, the Earth curve calculators would not be as accurate as they are. I hope you guys all have a nice night.